Well, guys, my project with my weight 1 modular form over gamma 1 of 3 is on a hold for the moment, so let's do the last problem of section 4 in the meantime. This is formula 4.3, and I have written the definition of J operating on a matrix and Z given by this. I'd rather like to write this, and then it's the square root up here, so it must be 1/2, and then this is moved to the other side. That actually gives a problem. You see, this square root must be on the right side here, and when we take the inverse, then we end up on this side. But when we take the square root using this, oh my God. So that introduces a minus. Well, let's see what happens. Oh, we actually need no Z here. All right. So let's try and verify it with minus I and t, where we know phi is invariant. So it's 0 over -1. I thought that was 0. Oh, A, B, C, D. So I'll just need to check that. Well, actually, 0 over ±1 is per definition equal to +1. So the right-hand side, -1, and D is equivalent to 3 modulo 4, so that's I to -1st. That gives the imaginary unit itself. Let's just do it. So it's -1 to -1/2 phi of Z. So that's 1 divided by which one do we choose really? my immediate idea is you should give minus I theta. The translation should be trivial. Yeah, that's the square root of 1, that gives 1. So we just need to check the right-hand side. This gives plus 1, and E1, that is 1. So it gives plus 1, and we get minus 1. So it seems it's the wrong sign both times. All right. And then we have alpha 4. And there we need the formula from the book. It's formula 3, 4. So that's 4 set to the order of 1/2. We'll just write what this gives before completing the formula to see what the factor must be. So first the square root, no, the determinant to minus 1/4, it's 4, square root 4, that's square root 2. And then it's 4 set to minus 1/2. And that's, isn't there anything more to say now? And this is 2, so it's 2 to minus 1/2. That it should actually have cancelled somehow. We'll have to look into that. Oh, we still need no, and then z to minus 1/2. Oh, it's actually all right. Here we have 2z to minus 1/2. And that means that it's equal to I to 1/2 times this. To use that, we need to divide by I to minus 1/2. So that's multiplied by square root I. So we divide by square root I over here. Now we have to take care, because here we take the square root we have minus I and take 1 divided, the square root, and then 1 divided by that lies over here. And I to minus 1/2, I to 1/2 lies here. Oh my God. I just need to check getting the right square roots. That seems to be quite a nuisance to me, operating with orders of 1/2. But that's of course the problem from the beginning. I'll just make a break, cup of coffee, and get that right. I've had my cup of coffee. The sun has come out, it's more light now. I had a cognitive dissonance here, and I found the reason. You see, when we move this to the other side, it's the reciprocal we get, and a number up here, it gives the opposite argument. So that ends down here, that ends down here, etc. So this area is mapped to itself. So therefore it's a plus here, and therefore this is plus as well. So that was the cognitive dissonance, and I realized at several occasions I've stopped recording when I have a cognitive dissonance because it's difficult to sort that out without being distant to the problem, to be able to see it from the outside, which I am not while recording. And then the last generator, I thought this would be the formula, but then the generator they had was this guy, and I think we should maybe, what about taking out that minus? So it's just 1/nth, which does nothing, and then a t to minus first a. So we have the formula for a4, and now the generator st to minus 4th equals one nth alpha t to minus first alpha. So we just operate on that. One nth does nothing. Alpha, that's a factor I to minus 1/2. T to minus first does nothing, and alpha gives another factor I to minus 1/2 theta, which means we end up to minus I to minus 1/2 theta, which is I theta. And we have to verify it. It was -1, -4, -1. And we have to verify it with this expression. C over D, J gamma point Z. Oops. C over D, epsilon D to minus first. C, that's minus 1/4 over -1 E epsilon -1 to minus first. This is -4 over 1. They were both negative, so that changes sides. E -1 that is I to minus first, and minus 4 over 1, that's of course 1, and then it's minus I to minus first. Oh, that was what we had here. So they agree. Lovely. So 4,3 is verified for the generators of gamma naught 4. And, well, this is trivial, really. We just need to see that it's actually beta set we get here, but I really don't want to do that. Conversely, if the theorem is proved, then it implies the relation. That's just as trivial. It's just formal nonsense. And, well, this is trivial, really. We just need to see that it's actually beta set we get here, but I really don't want to do that. And, well, this is trivial, really. We just need to see that it's actually beta set we get here, but I really don't want to do that. And, well, this is trivial, really. We just need to see that it's actually beta set we get here, but I really don't want to do that. Conversely, if the theorem is proved, then it implies the relation. That's just as trivial. It's just formal nonsense. So that's what I'll do to problem 3.